Hello, thank you. Good afternoon. Thank you also to the people online. I cannot see you, but I hope you can hear me well. Uh, Thank you for the invitation. I'm replacing my head of unit, Martin Bailey. He couldn't make it. Also, my director, Lucilla Scioli, because of other engagement, couldn't make it, but both they passed the message of gratitude for the invitation to the AI office. So I'm coming from the AI for Societal Good unit. And I have to say that I read the report and it's very, very good. I really got very good insights and I saw the connection got on what we do in the AI office. For instance, these are keywords on things that we do in the AI office. I got the concept of AI, the footprint, but also the handprint, how AI could be used for both things to minimize the environmental impact, but it has also an environmental impact using AI. So we need to reduce this impact. But in the report, I saw AI for urban data, AI-assisted urban predictive modeling, decision making, AI models to generate urban layout designs, specifically engineered to be more resistant to urban flooding. And also the need to invest in opportunities for AI for the sustainability sciences. And these are the connections on what we try to do in the AI office. What we call local digital twin in the report is called urban digital twin, but it's the same concept. Basically, if I refer to local digital twin, it's the same. So my unit, we drive AI innovation with cutting edge models, solving real challenges for cities and governments. And one of the challenges is how to make the planet more sustainable. We tried in the geopolitics, we cannot be naive. We also try to strengthen, and by developing these AI innovative models, we try to strengthen Europe's capabilities and safeguarding our sovereignty. So we are not fully dependent, at least when it comes to developing AI models. So the key areas I will go through quickly is one, we cover the area of digital transformation, smart cities and communities. We also work on innovative models to apply to society for the public good. We also develop international cooperation on AI, and we aim to have international partnerships with like-minded countries to co-develop AI-based solutions and innovative AI models. Just in a nutshell, and it's also mentioned in the report, this is more or less what the starting point for us. Cities, they face challenges that AI can help solve: mobility, energy efficiency, waste, infrastructure, service delivery, and environmental issues. And that's why for already a couple of years, we are working on the concept of a local digital twin or urban digital twin, that is a digital replica of a city to solve complex problems. Complex problems, the problems are not easy. We have to make decisions, but the decisions cannot be made with a finger in the air, like how to ensure mobility, but at the same time reduce pollution. So we use a digital replica of a city to help solve complex problems by applying AI-based algorithms, allowing for simulations that sometimes they need processing capacities, high or less high processing capacities, where citizens can be engaged in these simulations via immersive technologies. And this is the concept of Cityverse, to choose optimal scenarios so decision makers at the end of the day can simulate different scenarios and make the decision on which is the best scenario for the city. So one of the things we do is we develop a local digital twin toolbox, a set of tools with 6 AI models that cities will be able to use as of next year. Open models of AI, for instance, for energy optimization, to design low emission zones and reduce energy waste, to improve air quality and sustainability. And some cities in Europe are already using this type of models. Environmental health pollution propagation, to monitor the pollution, how the pollution is spreading in the city, and assess the impact in order to make informed decisions on how to minimize this impact. Urban mobility is one of the key areas, of course, how to optimize traffic flows. And it's in the report. I saw a good example of this It's a combination of public transport, private transport, and accessibility. Then we have urban planning, testing land use and infrastructure options to grow a more sustainable city. And the building environmental footprint, we have developed, and it will be at disposal of the cities, the 3D cartography of all the buildings in the EU with some kind of metadata information, typologies of buildings, footprint, environmental energy efficiency. This building data set has been implemented by pulling data from different repositories in the EU. So with this building data set, you can already run scenarios and work out what is the environmental footprint in a city, neighborhood, going to the level of a building. What I'm presenting here, we need to scale it up and we need to engage cities. This is the concept behind a new consortium that was created last year and the European Union is supporting. It's called Local Digital Twin Cityverse, European Digital Infrastructure Consortium. And we have 14 countries with cities behind. The consortium now is, let's say, starting in earnest. Actually yesterday, today, and tomorrow, they are in Barcelona in the World Congress, Smart World Congress, and they are presenting what they do, what they intend to do. And in a nutshell is to create an EU ecosystem of advanced AI solutions for cities. It's also a way to engage and to connect cities across the EU, promoting smart urban environments and new technologies like AI and local digital twins that can be used for decision making. And they will target AI for smart urban planning, reduce congestion, and enhance air quality. And the goal also is this decision making, you have to do it in a democratic manner, in a transparent manner, as opposed to other powers in the world. And I'm not going to say the name of other countries or areas in the planet that the decisions are not very democratic. So you can engage citizens, major stakeholders in the decision-making process through simulations and immersive technologies. This is one area, the smart cities, local digital twins. The other area is applying AI for the public good. And here we are working in 3 major topics. I will start by the topic of health that maybe is more disconnected to the topic of today. We are promoting we are training AI models to improve diagnosis of cancer, breast and prostate cancer. And these models will be offered to, of course, to hospitals in the EU, but also to countries in need, like in Africa. One area that maybe is more connected to a green planet is electric grid optimization. We are going to develop and test AI tools for a smart grid optimization in urban areas to accommodate fluctuating demand and renewable sources. Now with the economies becoming more electrified, you have peaks of demands, peaks of consumption, and at the same time, the energy sources they have peaks. If you use renewable energies, it's not the same in the middle of the day that early in the morning. So you need to introduce kind of artificial intelligence and kind of intelligence into the smart city to be able to cope with these peaks. And just what is more relevant here is disaster relief. We are working on a suite of AI models designed to enhance the capabilities in the EU for crisis management and emergency response. And I will explain this in the next slides. One thing that we are doing is to set up, to create local digital twins, and it's been in the report for flats. Local digital twins, so you can get a high resolution of the terrain, high resolution of climatological and meteorological models, and you can work out different scenarios for floods and what could be the impact of the floods in a city. And the case of Valencia is very clear what happened last year, but also parts in Italy, in Emilia-Romagna, they have recurring floods. So this way, urban planners can anticipate and prepare the cities for these scenarios that are becoming more recurrent. Instead of 100 years, probably because of the global warming, these scenarios will happen every 20 years. And so basically in disaster risk management, we work in digital twins for urban preparedness, floods. When the disaster is happening crisis, we are developing AI-based platform for multi-hazards, wildfires and floods. And then for reconstruction, we are working on a digital twin for reconstruction. And very quickly, and I will finish the presentation. Yeah, very good. So for crisis management, due to global warming, the occurrence of natural disasters is increasing. So we are applying innovative AI models to predict better the evolution of a disaster, and basically wildfires that is touching Europe and many parts of the world. With there are more and more models that they can model the nature of a wildfire. And this is a multi-hazard platform. It will be open. It will be used by the EU, by the European Civil Protection Mechanism, but also it can be used by the Latin American region, by Africa. It will be offered as open source, starting by wildfires, but extending to floods next year. And finally, digital twin for reconstruction. This is when the disaster has struck a city and you need to rebuild parts of the city because there are major floods, or in the case of Ukraine, because there is an external aggression, human-made aggression. So this digital twin for reconstruction with satellites and drone images will be able to assess the extent, the severity of damage in buildings, then creating a digital replica of the city with the partially damaged buildings. You can simulate reconstruction projects and have precise estimation of the cost per building. The tool is micro. It will target buildings. And you can also do better urban planning by once as you have to reconstruct and to rebuild city, you can use better urban planning design and energy efficiency, different parameters. And with this precise cost estimate, you can track down throughout the entire reconstruction project the cost and if there are deviations. That will ensure transparency and accountability. And the tool is being prototyped and is being tested already into cities in Ukraine, Bucha and Mykolaiv. But now we are starting the implementation phase, the co-design of the final version for production services with the Ukrainians. But the tool can be used also in Europe, in other parts. And it will minimize fraud by having precise cost estimates. And the last slide, I promise. International cooperation. We are involved in different initiatives in the world to scale up these AI-based solutions and to offer as part of international initiatives of the EU to countries in need, especially Africa and Latin America. So that's all from my side. Thank you.
Thank you, Miguel. Thank you so much for sharing the work you are doing in the AI office. Thank you. Okay, thank you. Thank you again. Let's turn to the heart of today's event, which is an exclusive preview of what's inside the reports. And to walk us through its scientific foundation, key findings, and key recommendations, we are joined by 4 of the report's lead authors, representing the 3 organizations behind the remarkable collaboration. So first, Maria Schewenius, who brings deep experience in translating complex sustainable science into action. Welcome, please take a seat. Then Victor Galaz, leading thinker on global sustainable and emerging technology. Please take a seat. Both from Stockholm Resilience Center. Then from the Potsdam Institute for Climate Impact Research, little name PIC, Jonathan Donges, who focus on climate tipping points and how complex system modeling can help anticipate and manage global risks. Welcome. And the last one from Google DeepMind, Drew Purves, whose work focus on the use of AI to model ecosystem, natural process, showing how advanced machine learning can deepen our understanding of the biosphere and inform better environmental decision. Welcome, the floor is yours. And you have one mic next to you, Drew.
Okay, I heard an echo, so now it seems to be on. Yeah, and increasing loss of stability is also something that we need much more information on and tools to study it. And overall, this the challenge is that we're facing that the planet is really quickly moving out of the interglacial glacial variability of the past thousands of years, out of the Holocene that has provided a safe haven for human development over the past 10,000 years, into unprecedented futures. And one key risk that is related to this destabilizing Earth system in different dimensions are climate tipping points. So it's a key area we are working on at PIC and in the collaboration with SRC and others. And this is highlighted, for example, by this policy report that was published last year here by the European Commission, pointing out that Earth system tipping points are a big threat to Europe. Tipping points are critical thresholds in the Earth system that can lead to large changes that are detrimental to human societies and the biosphere when, for example, certain levels of global warming are crossed. Beyond 1.5 degrees of warming, we are entering a high-risk zone in terms of tipping points. This is shown very clearly by the Global Tipping Points report we've published together with University of Exeter and other partners only 3 weeks ago. We are already with 1.2 to 1.3 degrees of warming currently in the high-risk zone, entering for the Greenland ice sheet, Western Arctic ice sheet, tropical coral reefs. Importantly, they are already in progress of dying off, of actually transgressing tipping points in different regions. Permafrost and the Labrador Sea current are also under threat already at the current level of warming, and certainly between 1.5 and 2 degrees. And tipping point science is an area where AI can help us to reconstruct the dynamics underlying these systems and to improve early warning signals, for example, of approaching transitions. This is something that has already been done in first work for the subpolar gyre, for example, for the AMOC, the Atlantic Meridional Overturning Circulation systems that are very, very important for our climate in Europe, as you can see. And yeah, so this is much more progress is needed in this area. And finally, of course, we need to acknowledge these risks and navigate a great turnaround towards a safe and just operating space for humanity out of the high-risk zone that we're currently entering. And this encompasses a lot of complex social ecological challenges that where AI can help us to improve our modeling, our data processing capability, and decision-making. Thank you.
Hello, everyone. I'm Drew Purves from Google DeepMind, and this is a launch event. So I wanted to launch straight into an overview about why so many of us are so optimistic about the uses of AI to address the kinds of sustainability challenges that Jonathan just outlined. Firstly, AI has already led to dramatic advances in several key adjacent domains. These are a couple of examples from my Google colleagues. On the left there, AlphaFold, which has created an accurate prediction of the shape of every known protein. And on the right there, our deep learning-powered weather forecasting system, which is not only state-of-the-art for weather forecasting in general, but can accurately predict the tracks of cyclones. This is also the age of these giant agentic LLMs, like Google's Gemini, which can help almost anyone with any task. And we've got used to that now, but we ought to remind ourselves how amazing that actually is. But let's look at some of the more specific ways that AI might help with sustainability. On the left here, this illustrates the idea of breakthroughs, by which we mean AI-powered discoveries that sort of change the constraints around sustainability challenges. In this case, we're looking at people are already using AI to optimize the design of materials and otherwise the design of solar panels. And something like that could change the constraints around the energy equation. But beyond breakthroughs, equally, or perhaps even more importantly at the moment for many domains, is the idea of AI feeding through into complex decision-making. AI can help us to extract data about both the human and the natural world. It can integrate that data together with other sources of data in order to make predictions. And then we can feed that data, those data and those predictions into AI-powered interactive decision-making platforms to help people more confidently make the right decisions around sustainability. So I want to go over 3 of those very, very quickly now. So if we look at the data side, this is illustrated quite well by my personal domain, which is ecology. So we can now put bioacoustic monitors, wildlife cameras, or we can extract eDNA from ecosystems, and AI can help us to process the vast streams of data that they produce in order to extract the salient signals, for example, species ID. But a lot of data is locked away in the form of documents, maps and PDF documents and all sorts. And these agentic LLMs can help us to both discover those and to extract the relevant data from those. And AI can help to empower human data gathering. Here's an example of iNaturalist, which I have on my phone. And this is helping citizen scientists all around the world to take species observations from the field, again, AI powered. Now, if we look at so that's the data part. If we go on to the modeling part then, one example of modeling is mapping. So iNaturalist now has this geomodel system. So those data are aggregated together to produce distribution estimates for each of the species. And on the right there, once again, the WeatherNext platform from Google predicting those cyclone tracks. And this, I wanted to illustrate another use of AI for prediction here. This is one of my favorite, it's not my paper, but I wanted to highlight, it's one of the papers that I've been the most impressed with that have emerged in the last couple of years. It's called Pandemic LLM. I wasn't involved in this work, but and this is a system that predicts outbreaks of diseases and loads on hospitals ahead of time. What's pioneering about this work is it's using LLMs to bring in lots of different sources of data which are in language form, like news articles and other forms of language data, integrating that together with other data, and then it's using the LLM as a core reasoning agent as well to help with the actual predictions. I think it's really pioneering work and quite thought-provoking about whether an approach like that could be generalized. And last but not least then, this idea of interactive AI-powered decision-making. The idea here then is that you can, in one way or another, use AI to knit together these different data and predictions and then have groups of stakeholders. Important decisions are always made by groups, somehow interact with all of that through AI to make a better decision. One example, an early example of this, I would say I think this is the least developed area of the application of AI to sustainability, but we're starting to see some really pioneering uses of that. I think one of them, which caught my eye recently, is from the World Resources Institute. It's called Global Nature Watch, and they have a lot of geospatial layers, and they're then surfacing that through an agentic LLM system so that people can express a question in natural language, and the system can answer those questions and even generate charts and figures on the fly. But we'll also have another great example of interactive AI-powered decision-making later from Tellman. And also, I wanted to give a shout out to you, Masahiro Rio, who's in the room. I think you're doing a lot with agentic LLMs as well in the field of nature and biodiversity. So it is a growing field, but I think it's probably still the least developed. And the last thing I wanted to say was, of course, we looked at some of the individual ways that AI can help with sustainability then, but really what we expect is that it's in the combination of all of these together. And I think when we take the sum of all of this, AI for data, AI for modeling, AI for decision support, in this multifaceted challenge, the polycrisis of environmental sustainability, I think we're really on the cusp of something genuinely transformative in terms of our ability to both understand and address sustainability worldwide. Thank you.
It's me. Hi, good afternoon. Nice to see you all here. Thanks, Norrsken Brussels, for hosting us. A deeper dive into the report, like what's actually in the report and what is the niche for the report. So this journey began 2 years ago, I think, because we saw a gap. So there's a lot of interest in AI for science in general, both in Europe and around the world. But when you look at these reports, you actually see very little AI for sustainability science. And maybe climate science is mentioned briefly. There are also a lot of reports and projects that apply AI for sustainability, like tangible hands-on projects on biodiversity, monitoring, or other types of stuff. But those are not really focused on the science. So I think this is, if you're asking what is new with this report, the report tries to fill this gap. if you're interested in the science of a just climate transition or to become biosphere stewards, this is where to go for this report. So we know the potential is there, right? So as Drew mentioned and Jonathan mentioned the challenges we're facing, there is some potential of AI for this type of research, but no one has really mapped that potential. I mean, we can list 200 projects where AI is being used. So, but what does it tell us about the systematic potential of AI for sustainability science breakthroughs? So that's what we did. We chose 8 issue areas. You could have picked 20, you could have picked 5, you could have picked other areas, but these are the areas that we chose because we think there are both exciting scientific challenges and needed, that can give us insights that are needed for people and economies around the world. So we chose, so these are the 8 issue areas, all very inter-transdisciplinary. So first of all, understanding a complex Earth system, it's not just about the climate, it's also its interactions with land, oceans, forests, etc. The other issue area we chose was nature's contribution to people, ecosystems, ecosystem services, biodiversity. The third one was focused on fresh water, both blue water and green water, for those who are familiar with the terminology. And the fourth area was on our oceans and our blue planet. The other 4 areas we chose are slightly more social, even though all, of course, are social ecological in my world. Interconnected shocks, or what some people call polycrises, are the clever ways that we can use AI to analyze data or gather data or even give advice or projections on polycrisis in a world of polycrisis. Urban planet, the planet is urbanizing very quickly and also facing big challenges due to climate change. How can we use AI in that type of, to improve and make cities more resilient? Collective decisions, how can AI make us, can help us make better decisions? And then science communication. Are there clever ways that we can use AI to better communicate what we do? So those were the 8 issue areas that we chose. Again, you could have picked more or less or others, but this we believe was a good beginning. What did we do in more detail? First of all, we conducted a literature analysis. So of course we used AI to do part of that analysis, ended up with 8,500 articles. Maria will go through that briefly. We also combined that analysis with expert assessments. So each area has its own chapter by domain experts, where we look at potential, opportunities, evidence, but also risks and limitations. What are the things we need to do? So not just hyping, but also looking into what are some potential limitations. Together with that material, we did collective assessments of the whole areas and a synthesis. And in the end, for those who are interested, we provide some recommendations. Recommendations to our colleagues around the world, to policymakers, funders, philanthropy, and private sector. I think each of these actors have something they can contribute to in this domain. Yeah, now the literature analysis.
Right, this is on. Good. So the report is AI for a planet under pressure, which hints both at opportunities, but also risks and limitations. And it can be a challenging work, but with inspiring expert colleagues like this, projects like this report become an interesting pleasure. So I'm here to talk a bit about the literature review that we did in this project. It was done primarily by myself and Eric Schiff-Koplias, a PhD candidate at Stockholm Resilience Center. He could not be here today, unfortunately, but he was very much leading that effort. And then Victor and Ingo Fetter, who is here, contributed to the chapter. If we briefly look at a timeline of what we mean when we talk about AI, we have divided it into 3 generations of AI methods. We have the earlier classic machine learning, which consists primarily of supervised machine learning, unsupervised, and reinforcement learning, and that is characterized by the absence of neural networks, you can say. So it's classification and regression tasks, a lot of it. A significant paper that came out in the end of that period is the AlexNet paper. The title is longer, but the paper presents AlexNet, which was a neural network for identifying objects in images, and that transitioned into the next generation, which is focused deep learning, and that is characterized by the emergence of neural networks. We then go into new AI, and that is characterized by the emergence of transformer architecture. And essentially, the difference there is an even higher degree of autonomy. We have processes that can look at the context of input information and run several processes simultaneously instead of reading data in sequence. This is the literature review that we did. We started by manually identifying 825 articles that constituted the training set. Let me see. The articles are from 2020 until 2024, and they had at least 10 citations. And they were then used to train the AI tool Rayan, which identified another more than 19,000 articles. From that, Rayan selected or recommended which articles to include in our review and what to exclude. And we had a total of 8,504 articles that were recommended to be included. Those articles are the basis for the map I will show you in a minute. Out of those 8,504 articles, we could categorize 5,600, or Rayan could categorize 5,600, which are categorized into the 8 issue areas in the report. Yeah. So now we're starting here to look at the results. So we have the issue areas here in the report, we have the 3 AI generations, and we have a range of AI methods. We can see here that different issue areas are represented by different AI generations, or the different AI generations are more or less prevalent in the different issue areas. So for example, we have the quite biophysical modeling heavy areas, interconnected shocks, earth systems, and they are fairly dominated by classical and focused deep learning. If we look more at, for example, the urban planet, collective decision making, to an extent communication, even though that's a tiny field down here, then we see that these subject areas that build perhaps more on participatory processes, they are more signified by the use of new generation AI. And what are these generations then? Well, we have here these different AI methods. So the NN are neural networks, and they are mostly connected to the focused deep learning era. Down here we have transformers, we have UNet, belongs more to the new generation of AI. I would recommend you to study this image more in detail because it's a lot of information to take in, but essentially you can see how different methods are differently prevalent in different issue areas. If we then move over to the map I briefly mentioned, this map builds on data from the 8,504 papers in the literature review. The blue dots represent the 10 countries that are most commonly occurring in that data set. And it means that the country name has been written in the title, abstract, or keywords, or the first or second author is affiliated with that country. And what we can see here is that large world economies dominate. We have a heavy dominance of the US, Europe, China, India, Brazil and Australia are also included. And we have 0 mentions in the countries that are marked by black dots, and we have 1 or maximum 2 mentions in the countries that are marked by gray dots. The countries that don't have dots have either 3 or more mentions, but they don't qualify as the top 10 countries. What we can see here is that, like I said, these are large economies or high income countries that are mostly prevalent. And countries that often are the most affected by changes, such as urbanization or land use change, sea level rise. I meant to say sea level rise. They are the least included often. So this is a selection of, I would say, black and gray dots, but 0, maximum 2 mentioned countries. So there are more countries that are barely mentioned, but these are the selected ones. And you can see here low-lying islands, for example, they are not even included in this data set. We have rapidly countries that undergo rapid population increase, like Niger, Mali, barely mentioned in the data set. So there is a heavy geographical bias that can influence both the data that's collected, how models are developed, who is using models, for what purpose. So this raises questions of who is developing AI, for whom, and who can use it. And by that, I hand over to Victor.
So just to some general conclusion, how are we on time, by the way? It's okay? Yeah. 2 minutes? Okay, yeah, that's not gonna work. 3 minutes. So very quickly, so we went through the 8 issue areas. We have done deep dives, literature overview, and analysis. At the last part of the report, we wanted to compare the areas. Like which areas have made the most advancements, which areas are falling behind or would need more investment to make quick progress. So that's what we did. We did an internal survey with the authors. So we're talking about 20, 25 people. This is not a global survey, it's an author survey, but we're all domain experts, I think. And we had so we asked about 3 things. So there are 2 dimensions here, the y-axis. How well are AI models performing in this issue area, according to your assessment? From 1, like very poorly, to 5, very well. And the other dimension, the x-axis here, data access and quality. How well is data in this domain? Is it easily accessible? Is it correctly labeled? Is it usable? From 1 to 5. And then we also asked people about availability, like how available are these insights and model to people outside of academia? Like, are they very accessible or not very accessible? So those are the color dots. So that means we have 4 squares, right? So we have issue areas where AI models are not performing very well and where data is lacking. We have an area where models are quite well performing, but with low data access and quality. An area with low performance in AI models, but a lot of data. And then, of course, where we want to be, probably, where we have AI models that are performing well and where we have good data to use. So these are the 8 issue areas. This is our assessment. So collective decisions would be the ones that has the least maturity, if you want to use that word. And that means AI models that are supposed to be used to help us make sense of collective decisions and medium access. And then we have some sort of medium area, the blue planet, nature's contributions to people, and urban planet is performing better though. Notable that the polycrises or interconnected shocks types of models have low accessibility, I think. And then, of course, other areas that perform better. Sustainability, science, communication, for example, have high accessibility and perform pretty well and have some data or good data. Whether the Earth system community, that would be you guys in Potsdam, Jonathan, have lots of data and actually have quite advanced and good performing AI models, but their accessibility of those insights have been assessed to be quite low. So what you can see here, I mean, again, this is just our assessment, but that means that if you're interested in the science of these domain areas, you need different types of investments. For some, you would just need to ramp up infrastructure and science just to get this off the ground properly, the data and the models. And for other domains, it's maybe more about making what we have usable. For something to discuss, very briefly, conclusions, 1.5 minutes. First conclusion, I mean, our assessment from the literature overview and the deep dives, we do see a lot of potential of AI as a method to advance sustainability science type of questions. We can also see that it's not just about finding new causal relationships or unpacking complexity, it's also supporting decision-making. It can do that, and it can help clarify and communicate complex environmental challenges. We've seen many examples of that in basically all of the domains that we studied. But you need to do this carefully, because in each of these areas, we also identify issues and risks that need to be mitigated, both the material footprint of these models, but also things as bias and hallucinations and unequal access. Fourth, we do find, and there are many, many good examples of scientists mitigating and reducing these harms in very clever ways. So principles for open data, or fair data principles, or data sovereignty principles, collaborations that exist already. So even though there are many, many challenges and risks, we do see a lot of good innovative approaches from scientists mitigating and tackling this hands-on. And then the last point, which I think is interesting, is that by pioneering these kind of responsible uses, we can actually unlock quite interesting breakthroughs in this domain. And it is a balance, as we write in the report, between urgency and care. Urgency in accelerating this type of research, because the world is changing, the climate is changing rapidly, but doing that with care, doing that in collaboration with people, mitigating harms, avoiding bias, and other things. And it is possible. So potential. Now, Tellman.
Yes. So, time for questions. I had so many, but I will ask you the questions when we mingle at the networking. Please. Thank you. So now it's time for 2 deep dives. The first one will take us to the heart of the cities. So please join me in welcoming Tellman McPherson, Professor and Director of Urban System Lab at New York University. His work focuses on how artificial intelligence can help cities adapt to climate change. Welcome.
Thank you. It's great to be here. So I'm going to talk about one of the urban issue areas and highlight a few of those 8 issues that Victor and colleagues have been describing. And I just want to motivate this a little bit and to talk about the importance of cities and why, as we also heard from the very first speaker within the EU Commission and the AI office here, cities is a major focus. You may know some of these stats, but I'll just throw them out a little bit, that the carbon emissions on the planet, 70% of those are driven by cities, right? 70% of the electricity use is in cities. Cities are where we concentrate people, infrastructure, and our economies are concentrated in cities. So anything we do to transform the way urban environments are designed and developed has planetary impact, right? It's also important, I think, to think about not only where we are now, but where we're headed. The majority of the urban population growth on the planet will happen in the urban environment and in cities. And yet at the same time, we're seeing that cities, even with all of the technological advances we've had, are still developing largely on a 20th century model of development where we're paving over nature, squeezing out green space. And that does things like we heard from the former speaker, which is makes water flashier on these impervious surfaces. So floods are actually exacerbated because of the way in which we design cities, as one example, including how we make them hotter, et cetera. The thing I think is really important about the AI opportunity is that the challenge of redesigning and redeveloping in a way that moves us towards a better Anthropocene, a really positive future for urban residents on the planet, is one that has to take into account the complexity of cities. They're very complex. There's a lot of dynamic interactions that are happening in real time every day. And so we have to actually think about them not only as socio-ecological systems, but socio-ecological and technological systems. In the report, one of the things that we point out is the real opportunity space for AI. And again, as I mentioned, the urban areas are deeply linked with planetary concerns. So as we heard from Jonathan in terms of planetary boundaries, the urban driver of a lot of this shift in planetary boundaries is really important. And yet the AI opportunity there is very linked with our chance of transforming the way in which we design, plan, even retrofit existing cities. And I'll just give you an example. One we've heard a lot about, and Victor was just highlighting, is the data availability. More and more data is available to make sense of in urban areas. This gives us a real opportunity to harness that data for change. And on the left here, I'll just show a quick example of the way cities are starting to ramp up sensor technology. This is an example from some of my colleagues at NYU who are rolling out radar-based flood sensors so that we can understand in real time where flooding is happening. Now, this does more than just allow us to do better emergency response. This means we can train AI to automatically reroute taxis, buses, ride shares away from harm's area for even other types of mobility. It means now we can use that kind of data to validate and train AI models to predict where flooding will happen in the first place, right? This onset of new data is really powerful in leveraging AI to actually build tools that allow us to be more resilient. I think the question is, how do we do that in a way that's equitable and sustainable at the same time? I'm going to give you a couple quick examples of how this looks in this deep dive. One is thinking about the role of AI for urban predictive modeling. We heard a little bit about this already, but the potential here is really massive in our ability to forecast how land use will change under different scenarios. How, for example, heat or heat islands might be able to change under different development pathways, even down to very granular building scale, even smaller scale changes within any type of development project. We can start to model out how various traffic scenarios can be optimized, or where we can deal with energy challenges, especially these sort of peak moments that are happening and are likely to actually be even more of a concern over time. I'll point out also that explainable AI is really an opportunity space for us to lean into in the sustainability environment, because we can start to really reveal some of these inequalities behind different types of exposures that are underlying a lot of the environmental injustices that we have in cities all around the world. And we're seeing more and more the potential for models to integrate new types of social information, where people are, what their values are, what their perceptions are, what do they want, what do they need within their environments, and how we can bring that information into sort of real-time updates about how the city is functioning, where it's functioning poorly, where it's functioning better. Additionally, we're thinking about this, and I've heard decision-making has come up multiple times. Decision-making is key. Drew pointed this out. We heard this earlier, that in order to really move through these steps where we have tools that now that can be used to upgrade our decisions so that they're more effective, more impactful, more equitable, this is a place where AI has opportunity at every single stage, right? From problem identification all the way up to how we can optimize resource allocations and really monitor and evaluate performance, and then adapt and iterate so that we can continually improve. And there's a few examples here, again, of how we might be able to reduce congestion, reduce pollution through even just the problem identification, let alone how we might run scenarios to say, maybe this area should be rezoned, or we should develop housing in a particular way so we can not only have more housing, more affordable housing, but we can do that in a way that lowers the heat island effect, that reduces flood risk, et cetera. And there's multiple tools that are available here, including LLMs, that are able to take in many kinds of information and make sense of them. Again, this is getting to that point of cities are complex. It's a lot of different information to try to understand simultaneously. And AI now gives us some real opportunity to make sense of that. I'll give you one example of a tool that part of my team is developing, which is to deal with this challenge that we're facing in cities all around the world, which is rising flood risks and similar types of natural disasters. How do we normally do this? The normal way we do this is computationally intensive. It requires high expertise. You need hydrological modelers on your team, but it can work. right? We run a scenario, we imagine a certain amount of rain falling within a certain neighborhood or even an entire city area or whole watershed. And we feed in a lot of information into these bespoke physics-based models, elevation, terrain data, where the buildings are, where the impervious surfaces are, where soil is, where the vegetation is. And out of that, we can get predictions of where flooding is likely to occur. How long is it going to stay there? What depth does that water result in? Here's some examples from doing this kind of modeling, this hydrodynamic modeling in the city of Atlanta, Georgia in the United States. But this kind of work, again, is really intensive. Only well-resourced cities are able to do this around the world. This is an example of work that we've also done in New York City, where this kind of mapping for the entire city took 3 years to do, cost about $3 million. We have almost 2 million cities around the world that have the same kind of need, not just well-resourced cities. How do we change that? AI can help us change that, and we're in the process of changing that right now. The same type of modeling inputs being put into a range of different types of machine learning that can learn from those same model outputs and then can learn about how cities actually work and then deploy the same types of outputs for any city that has a similar type of combination of elevation, building footprints, vegetation, et cetera. So this is, again, is an example where AI, and in this case through this Climate IQ tool, can provide that input and then make it easy for decision making, whether it's through a user interface that's easily designed for anyone, even lay people, to be able to interact and understand their flood risk, or through APIs that integrate into digital twins or other types of systems that just need the data. But now AI can actually be layered in as a way to provide that data. So the last couple slides I'll just sort of emphasize in terms of the urban potential here. And one of the places, one of the locations on the earth that I think has the most opportunity to really fundamentally change sustainability on the planet is to start to advance this kind of comprehensive AI modeling for complexity, for the ways in which we need social information, ecological information, climate information, built infrastructure information, and building those realistic digital twins that can allow us to provide that kind of information. And then scenarios, of course. We're always running scenarios in urban planning. We're always trying to understand, if we did this, what would happen? If we plant more trees, will it cool the city, and by how much? If we develop a new neighborhood in this way, how much housing will it provide? What will be the cost? The scenario potential and this kind of impact forecasting within AI is really incredible, and kind of excited to see where this is going to go. And finally, again, coming back to the social and the people piece, there's a lot to understand about what people have or don't have and what they want or they don't want as we try to build cities that are actually more livable and more inclusive and equitable at the same time. 2 final points here. There are limitations. We haven't solved all of the problems with the technology now. One, as I think Maria mentioned earlier, the focus of training these types of models is generally in data-rich areas, which are generally in wealthy areas, and that doesn't necessarily mean that the learning we have there is easily exported or even applies in other places around the world. There are lots of different ways cities are growing and changing in Africa and Latin America and Asia, and training in, for example, US or European context doesn't mean that we're going to get the answer that we need. We actually have to be deploying training and working and co-producing in those areas. Additionally, despite all the amazing work that Drew's team and other folks are doing, there's a gap in how we really apply this to nature. How do we start to solve the biodiversity crisis in a way that recognizes that cities are expanding in every biodiversity hotspot on the planet? We're having impact directly through city development in every place that matters for biodiversity. We can do better, and I think AI has some opportunity there. And finally, as Victor pointed out, there's a lack of understanding and access to some of these tools that can be kind of complicated to use, and certainly complicated to build your own. So this training and this accessibility is a key piece, and that's going to be really important, I think, for us to deal with some of these other challenges like limited foresight. So some recommendations that come in our report. Hopefully you will download it and read it and help us work on this challenge, which is to embed this complexity thinking, this systems thinking into the way we actually design our AI tools, so that they're really starting to deal with the dynamic interactions that we see in real time. That we start to work on this literacy and accessibility problem and really start to build that out among planners and decision makers at all scales, right? From local neighborhood organizations to city to regions and to national and international. Additionally, we want to think about how we can make AI more explainable and more transparent. In the tool I just mentioned, We're building that with an open code, very transparent. One of the challenges with using a lot of these tools is that they're black box, and so there's trust issues. To solve the trust issues means we're going to have to open that up, and we're going to have to do that very intentionally. And finally, as I mentioned, research within urban nature and urban ecology and even beyond the urban is really key here. And as I think we'll still hear a few examples of this, cross-sector partnerships are going to be key to really drive forward this innovation. Public-private partnerships, partnerships between the private sector and academia. There's a lot of work there that's already happening, and we can sort of hold that up and be excited about it, but there's still plenty of work to do. So I'll stop there. Thank you very much.
Thank you. Thank you so much. Do we have Beth online?
Hi.
Hello. Hi.
Well, hi.
Okay, so it's deep dive number 2 with Beth Tellman, chief scientist and co-founder of Fruitbase, where she oversees the science team to map floats. And she's also teaching at University of Wisconsin-Madison. So now she's going to take us from the city to the skies. Beth, the floor is yours.
All right, thanks. Next slide. All right, thanks. I'm going to talk to you today about how we can leverage satellite data and AI to do a better job flood mapping, and more importantly, what we can actually do to solve and address problems of flooding. And I'm going to specifically dive a little bit deeper into climate justice aspects of this problem. My group is called the Social Pixel Lab, and we bring together social science and satellite data. And my company is called Floodbase, so I'll be talking about both those aspects. Next slide. So I'm so interested in satellite data, and it's become a really rich domain for AI. One, because there is so much data. Every year, more and more satellites are launched, and we're taking advantage increasingly of computer vision AI algorithms that have been developed often in the medical sciences and porting them over to earth sciences in satellite imagery. But satellites are really important, not just because there's a lot of data, but because they allow us to see where risk is changing on the ground now in ways that traditional flood modeling and physically based models struggle to do. So we can see where people are moving and what that means for risk in these images, and where floodwater moves and follows as we grow cities all the time, as Tellman was just mentioning previously. Next slide. And I won't go too into technical details, but I just wanted to kind of give you a sense of where the edge is right now, I think, in remote sensing and AI for satellite data analysis. Flood mapping is one of the many domains where this is happening, but we've really gone from this classical deep learning approaches that we talked about in this report, convolutional neural networks, long short-term memory networks. I have sort of the acronyms here. And we're starting to see, I think, for the first time, these new foundation models and transformer networks beat these more traditional focused deep learning networks like UNets, which are sort of the favorite of satellite-based remote sensing, and seeing these new AI models beat them. So these are kind of hot off the press results from my lab, where we try out some of these newer foundation models, Privthi, Clay, and DOFA, which are some really popular ones. And we're starting to see them outperform in these median IOU scores, these traditional UNets, which have really been king in remote sensing for a long time. And the exciting part, I think, is not just the gains in accuracy, but the fact that with very little training data, with some of these newer foundation models, you can get accuracy that is competitive or beats previous models where we had to spend years or a lot of money painstakingly labeling all of these flood maps. We don't really have to do that anymore. And foundation models is what's allowing us to do that. And again, I don't think this is just in the flood domain, but we're starting to see this in earth sciences. And you all have probably experienced it if you've been using Gemini and ChatGPT. These advances in language models are built on foundation models, and that is permeating the rest of the earth and sustainability sciences. And we're seeing it specifically in the domain where I work too. Next slide. And it's clear that better data and flood maps can be leveraged for adaptation. I started a company, co-founded a company about 10 years ago called Floodbase, and we have near real-time monitoring systems based on the latest AI technology. You can check out our models that we publish, where we fuse hydrology models with satellite observations. We use deep learning CNNs here, very similar to the approach that Tellman just talked about. And because we can model and observe flooding over decades in the past and in near real time, new insurance premiums and policies can be written based on those data streams. This is called parametric insurance. So a payout can be triggered based on an observation from a satellite, and you don't have to wait for an adjuster to come to your house and do a damage assessment. It can be automatically determined and the money delivered immediately, and can be used to insure non-traditional things. So for example, the city of Fremont in California purchased a parametric insurance policy that's based on our data, that's underwritten with Swiss Re and Amwins, so that they can get a payout when a certain percent of their municipality gets flooded, and they can use the money for whatever they want, not just reconstructing their legislative building, but to rebuild bridges or fund other programs. So this new data is enabling really important advances in climate adaptation. Next slide. But what if we want to do more than just use data for better climate adaptation? Can AI be used to fundamentally improve climate justice? This is so much harder. And I just want to kind of remind us all, this really comes from the environmental justice literature, and from discussions we've been having in my lab group led by Ufoma Ovienmada, who works on building tools with incarcerated populations in the US, really deeply rooted in co-production and environmental justice. That justice is a verb. So AI for climate justice is not just about, I've made some better data with AI and let's combine it with some other data, therefore we've done climate justice because we're working in the global south or in a minoritized community. It's not just about that. It's a verb, it's an action. It actually has to support coalition and power building, address fundamental mechanisms of oppression like racism or colonization or colonialism, and it has to be agonistic. And this means fundamentally questioning power relations and doing something that might be against state actions. So the data has to be from AI has to become part of a social movement and process if it's truly going to be used for climate justice. And I'm going to give an example of how we're trying to do that. Next slide. In my lab. So I'm going to tell this story about what's happening with flood dynamics on the US-Mexico border in South Texas. This is work mostly done by my PhD student, Lucas Belluri. He has a great podcast on flooding in the borderlands that's bilingual that I encourage you to check out. And flooding in this context happens in informal settlements called colonias. They're chronically flooding. And in one such flood event that occurred in 2008, when people were sending in their disaster claims to the US government through FEMA, which is our Federal Emergency Management Agency, they were systematically getting denied government support through a policy called deferred maintenance, where government inspectors were told to look at someone's floor or roof and say, hey, if you can't tell if the floor or roof was flooded because that person is poor and did not upkeep their floor or roof, let's call that deferred maintenance and don't give them a payout. And they were systematically applying that policy. Well, community organizations like Lupe, La Unión del Pueblo Entero, teamed up with lawyers at Texas Rio Grande Legal Aid to sue the government to say this is discrimination. And they won. And households got a cash settlement almost 10 years later. And starting conversations with these community-based organizations and lawyers, we thought, what if it doesn't have to take 10 years? Could we use AI and satellite data to prove that flooding is happening right now, and change the way that this system operates and address other flood injustices that are happening in this region? Next slide. And we co-developed a framework called Flujos, Flood Justice Utilizing Satellite Observations. And our framework is, and this can be applied really to kind of any AI, I think, in climate justice scenario, start with the theories of change of how will AI and data actually fundamentally redistribute power and address injustice in this area. And then we develop tools in a database, not just based on what does the flooding satellite images can see, but can we train the AI algorithms based on people's lived experiences of flooding? And I'll go through that in a minute, through human in the loop approaches, and constantly be iterating on a tool that's based in people's lived experiences that shape to their needs for advocacy, funding, managed retreat potentially, and other efforts in community empowerment that NGOs are working on in this region. Next slide. So I'll just show, kind of end with this AI example, kind of a part that we're doing of Flujos, which I think I would recommend replicating in other places. So we took a focused deep learning approach, very commonly used in remote sensing, convolutional neural networks, showed people our maps, and then had them draw all over them and say, this flood map does or does not align with my lived experience of where floods have happened. And we took those observations from people and we retrained the algorithm. This is called human in the loop, where you have a human really doing a lot more supervised learning in AI. Next slide, and I'll just show you quickly the results. So our original flood map, flood areas here are in orange. We were missing really key areas of flooded communities that are circled here in blue on this map. Next slide. And we retrained the algorithm. You can advance. Yeah, thank you. And reran an algorithm based on people's lived experiences. We're capturing flooding in different and new places by doing that. Next slide. And what we found was that, sure, we got a 10% increase in accuracy, and we were capturing these new places where people had experienced flooding. But I think the more important insight here, if you can go to the next slide, is that, actually the next one, I'm going to skip this one for time, is that involving people's human experiences in AI, it increases accuracy, but what it does more fundamentally is it increases people's trust and ability to see sort of themselves and their life and their experiences in the algorithm and understanding where the data comes from and how it works. And that is fundamental in getting people comfortable with and trusting the data to then actually leverage it in their social movement and process for change. So AI can enable better data, and this is not just in flooding, to enable adaptation. I think that's really clear. But we could also be maybe enabling these types of technologies and tools for flood justice, and justice in other domains in sustainability, if we're really involving people in the co-design at the center, involving them in the design of algorithms themselves to build trust and build power. Thanks.
Thank you, Beth. Thank you so much for being with us. Okay, so now that we have heard all our experts, let's move to the panel discussion. This is the moment when policymakers and industry leaders join the scientists behind the reports to explore how the insights we have just heard can translate into policy, innovation, and concrete action. So please join me in welcoming Dusan Schewenius, Principal Advisor for Digital for the Green Transition at DG Klima at the European Commission. Eva Mals, Head of Unit for Strategy, Digitalization, Better Regulation and Economic Analysis at DG ENF, also European Commission. Ilya Sakovidis, advisor on digital decarbonization at DigiConnect. And can we connect also Sid from the International Energy Agency? He's energy investment analyst. And also let's welcome Rafael Keynote, Director for Sustainable Policy at Digital Europe. Oh, good. Yeah. But those are policymaker industry leaders. We also want our superstars of the day, 3 researchers. First, Lan Wang Erlandsson, from Stockholm Resilience Institute. Please, yeah. Ingo Fetzer from the Stockholm Resilience Institute as well, and Maximilian Gelbrecht from PIC. Yeah, please. So thank you so much for being here. I know that you are many, many, many on the stage. So the first part will be like to make sure that you know each other. So I'm going to ask first to commission people to introduce yourself, explain why you're here, your perspective, and the angle that you will bring onto this topic. So we have 3 people from the commission. For them, it's like interinstitutional meeting, but for us external stakeholders, we are not used to seeing you all together. So we have DG Klima, DG Environment, and DG Connect. I will let you all introduce yourself and explain also why you're here and what you want to bring to the table. You have 3 minutes each. Dušan, can you start?
Yes, I don't know if I need to repeat, so probably my voice, no, it was for online. Okay. So Dušan Hrenek, Principal Advisor for Digital for Green Transition in Director General for Climate Action. I'm focusing with my team on using digital and space technologies for climate action. And of course, we are also focusing on using AI for climate action. So for me, the report is really excellent. I would like to congratulate to everybody who contribute to this great report, which is giving an overview of possibilities, opportunities of AI for sustainability, for environment, and for climate. And it's focusing also on risk, not only on opportunities, but highlighting also the risk. And that we should do it also in our work. From climate perspective, for me, it was interesting to learn more in 3 areas: on earth systems, also on urban environment, and on decision making. And there are areas that we are working on it together with our colleagues in other DGs. And we have to connect like climate and digital transition, digital transformation, that without effective use of digital technologies and AI, we are not going to achieve our ambitious climate objectives, climate neutrality by 2050, and also to become climate resilient. So maybe let me connect it to our work, what we are doing with using AI for climate action. So first area, earth systems, earth modeling. On that, there is another excellent initiative from DG Connect, Destination Earth, and it's building digital replica of the Earth using also AI. And we started with 2 digital twins on weather extremes and early warning. And early warning and adaptation. So that's extremely important together with the European Space Agency, EUMETSAT, and ECMWF, European Center for Medium Range Forecasts. And that we would like to use also for our European Climate Adaptation Plan that we are going to present it next year. And I was listening very carefully on urban initiatives, because there is something that is very close to us that we are now trying to use better AI for cities. And there are many excellent initiatives, like Miguel presented, Cityverse, local digital twins for cities. There are many other initiatives like Horizon Europe mission on cities, also on mobility, on environment. And there are hundreds, maybe thousands excellent projects, but we need to scale them up, replicate. It's not so easy as Tim highlighted, but we should do it. Sometimes many good projects, they are sleeping. They were finished after financing is finished, and they are not used. So we need to help cities to use it, also to give them more technical assistance in order to replicate, scale up excellent projects and help them to reduce emissions and to be more resilient, so to support them. And of course, we need everybody, scientists, tech companies, local administrations, and I think that together we can really use AI effectively for climate action on all levels.
Thanks so much. Thank you. Can you pass the microphone to Eva? Eva, can you explain the work you are doing at DGNF and how complementary is it to the work Dusan is doing? Thank you.
Thank you, and good afternoon to everybody. Thanks very much for having me today. My name is Eva Malz. I'm in charge of strategy, better regulation, digitalization in DG Environment. And as a well-trained bureaucrat, I will be sort of intervening from these three different caps that I'm wearing in my job. First of all, congratulations on this great report. That I can tell you, just the cover makes me feel like I am in a botanical garden. And if I add the table of content, when I circulate it to my colleagues, I assure you this highly increases the readability of the report. So both on the aesthetics and on the insights of the report, congratulations from my side. And I wanted to flag three elements of interest to my job, of the work of my team, is first of all a high expectation on how AI should revolutionize the way we do policy making at the EU level. And this is valid for climate adaptation, but equally for environmental policies such as nature, such as water, such as pollution, circular economy. All these areas have, let's say, developed over time based on certain type of modeling that is sort of bound to their universe. So we look at nature for the sake of nature. We look at circularity for the sake of circularity. And we, in this moment of troubled times, geopolitical tensions, security challenges that we are facing, all of a sudden having doubts whether these are the real issues that our citizens are facing. So this integrated analysis at climate, environment, together with economic and social consequences, how they are all playing out in urban context, in the context of economic sectors, in the context of populations and nations, is something that we have high expectations from. So not looking at nature for the nature's sake, but looking at nature as a basis for the economy, the sectors that that rely on this, for the society in urban or rural contexts that draws certain benefits, services. This is what we think AI can bring us in the future. And I will also be very frank that even now in today's context, we are heavily relying on AI when, for instance, analyzing public evidence from stakeholders. Without these tools, we are already not able to work as fast as we are expecting. The second element for me is the implementation of policies. And here I'm very excited to see in in the report itself so much focus on the public sector, on the public goods, and on the public authorities. I think implementation, and that's the big subject of this Commission mandate, we need to implement the policies that we have put forward, is how can we support public authorities that need to have the trust that the AI models they are working with are actually helping them and not misleading them. So that would be one of the questions for me, also to the academic society. How do you work? How can we increase this trust and really equip public authorities in better using AI when implementing policies? And the third element that I also want to flag is the simplification. There's a lot of talk about red tape coming from Brussels. And again, here, I think AI can be in some instances, not everything. We don't need to use AI for everything. But we, together with my colleagues, we studied some elements where we think, and we actually have seen demonstrations, for instance, of AI models applied to environmental impact assessment, and we have an excellent example, notably from Denmark, that shows it is possible to put certain amount of data studies in order to facilitate these heavy procedures that everybody is complaining, and help both the public sector but also the private sector project promoters in dealing with it. So I will finish here, and I have some questions, but I think 3 minutes I have exhausted, so I pass on the mic.
Elias, you know what to do.
Yes, hello. So good afternoon. Before I start to talk you what I'm doing, I wanted to thank the Norrsken, because that's a good setup to bring us together, and hopefully let's maybe get out of here, maybe keeping some names and contracts to follow up. Thanks to Timothy and Beth, because what you did was a perfect example of reality check. But what is missing is, Beth is already a company, but maybe you could work with Ecolab, because they are coming to us and saying, we can do all this mapping anyway for you. So you may not need to spend 3 million, but you will need to see what kind of service you can get with public-private partnerships. Thanks to the author, so Jonathan, Drew, and Maria, and Victor. It was a good job, but let me just go to the negative parts, okay? Wouldn't expect anything else from me, right? So the bias, you already said it. The bias is there because the papers were selected, and it's mostly where the developed world is working on. What I wanted to say is that we need one layer, one deeper layer of recommendations. Okay, so they are still too high level. So a recommendation where a funding agency will understand, okay, so how do I design call for proposals? How do we design call for proposals? And what I'm working on, and I need your help, and so anybody who is working in this area would like to, keep in touch. And that is the innovation canvas for AI. And by canvas, I mean that it has boundaries. The typical, of course, the natural boundary is the social and environmental boundary, okay? Environmental, you know very well. Social, it's kind of harder. It's too soft, and there are not really hardcore quantifiable metrics. It's very soft science. But I would also say economic boundary, because those are the 3-dimensional sustainability. So you have a triangle immediately, and you say, within that triangle, I want to operate, not to recreate the Kate Raworth's, the donut economy. Let's think more like a canvas. Because if it doesn't make business case, you will not go far. If you transgress kind of human rights and social issues, you will be pulled back. And if you transgress the environmental issues, which we do for decades as digital world, we don't care. For decades, we were oblivious to our impact to environment and climate. But we are there, and that's my job. I'm introducing my job. So for 6, 7 years, I'm pushing this world to notice that we have an impact. We are not virtual. Digital is not virtual. It's dirty. And it's more than energy, it's materials, pollution, biodiversity loss, in addition to climate change. And that dirty is not quantifiable easily. But the answer from digital world is we have a potential. And that's what you, Victor, were saying. The potential is there, potential is there. Potential I've identified for the last 7 years working on it. There is a great potential of digitalization to work towards triple crisis, but it's not realized. And unless we don't realize, unless we don't actually address the issues why this potential is not realizable, even your report will not go very far. So these recommendations have to go one level lower and to address the problem. Why the money doesn't go to this type of science? And Philip is here. Huh? He's like one of the few that has unit that is funding these things, but it's peanuts compared to how much money is spent on science. Why money doesn't go there? Why the public and private sector is not funding digital innovation in sustainability? Because it does not qualify for green finance. Why? Because we don't know how to actually estimate the net impact of these things. So the green finance is still struggling to see AI, it's not on the menu. So how can we do more to make sure that we actually get access to finance, sustainability finance for this type of work, and not only science or innovation finance? And lastly, and that's my canvas, the governance and the resilience. So if you make it a square, what I would like to work with somebody here is how do we recognize what are the conditions for financing institutions to recognize that this AI under this governance scheme is sustainable activity? So I can actually apply EU taxonomy or whatever private schemes, and we work with EIB, BRD, World Bank, multinational development banks, to put money on these kind of things with purpose and with governance rules, guardrails. So you don't go, transgress the environmental or the social boundaries. So second is us. How do we recognize what's a good AI application? What do we put in the call for proposals for you to say, okay, you have to guarantee me that you have X, Y, Z checks on human issues, on environmental issues, and on economic issues, that it's sustainable economically as well. Those kind of recommendations we are still far from. Those details we need to fill in, otherwise this will not progress, okay? And that's my job. I'm trying to make the problem, when you can solve a problem, make it a bigger one. So I'm trying to tell you it's a bigger problem than AI for climate. This is the digitalization world. How is digitalization supporting sustainability? At the moment, the only link there is very well developed is economic dimension of sustainability and digitalization. What we have done for some years, and COVID helped us, is the social aspect, health, teleworking, telehealth, and teleeducation, just because COVID really showed the power of digital, so we have impact on social. We are struggling to quantify the potential of the environmental benefit. If we do that, we may actually start moving and scaling. And the last, of course, is the skills. We measured 60% of cities and municipalities don't have a person that would even understand this conversation. So they will not spend the money. So they get money from us. They have money for green digital twin transition. By the way, those are my green twins in DG Connect, ADG, and climate and environment. And we are in a network. So we want to show member states that they should also, across ministries, work together, because in member states, it's even worse. It's like different planets. You go to Ministry of Development, Ministry of Environment, maybe they are even different parties. They don't talk to each other at all. So what we want to show is that there is an inability to even implement anything on a local level. 60% of the companies and 60% of local governments don't have people to implement these funds. Suppose you give them the money. So you get 3 million in New York. 3 million, let's say Valencia. There's nobody to understand how to spend it. So basically the money is put aside and it becomes just 3 kilometers of asphalt in some villages. Yeah. So that's how bad it is. Yeah.
Thank you so much. Thank you so much. I'm going to give the floor to Sid first from the International Energy Agency. I saw you nodding, so please don't hesitate to present the work you are doing and also reacting to what our European Commission representatives just said.
Thank you so much. Thanks for the invite. I assume my voice is audible. Okay, good. Firstly, I too would like to congratulate the authors of the study. I think, I went through it in advance of the event, and just to say that it presents a really excellent framework for us to understand what the full landscape is as far as the AI capabilities go, and especially where we should be looking further as we try to, as an agency, also try to build our own research and inform, our main stakeholders on the implications of some of the challenges in the coming years. But maybe before I kind of react to a couple of things, I should also just very quickly introduce my agency, because I assume that not everyone would be aware in this audience. So I work at the International Energy Agency, which is an international organization. We are based in Paris. Our member and association member countries, which are about 14 number, we together, these countries account for about 80% of global energy use and also emissions and also GDP. So it's imperative for us to work through some of these challenges of ensuring secure supplies of energy, of affordability, of sustainability, and these kind of and the interlinkages between many of these concerns. Now, I lead the work here along with one of my colleagues on energy and AI. So our job is to basically think through what are the issues at the intersection of energy and AI. And this obviously goes in multiple directions. So one, of course, is the more popular topic that is a part of the conversation often, with member governments and industry stakeholders and the energy sector in particular, which is about the energy demand coming from AI. And I mean, just to kind of just throw a number at you, we estimated that over the next decade, the electricity consumption from AI is likely to grow sixfold, through some of these data centers, which means that by 2030, midway through this point, the total electricity consumption from data centers would be equal to the electricity consumption from the whole country of Japan. So we are seeing, a significant rise of data centers. But the issue is that globally, and the conversation around the intersection of energy and AI, this number and this figure and this kind of aspect of the problem is the primary focus. But this is, of course, not the whole picture. There is a lack of understanding and appreciation of what it means to have productive uses of AI. That is AI that actually has material, positive, widespread impacts on society. And I think those types of interventions and those types of solutions are either not well known or not well appreciated, and therefore it's hard to even explain to policymakers, to regulators around the world on what they must do to unlock the benefits of these types of these tools, and therefore kind of push the boundary on what we can do. So our estimate in the study that we came up with earlier this year was that the total emission reduction potential from AI, this is AI being used for a variety of reasons, in a variety of interventions, for example, on improving efficiency of industrial energy use. This includes demand response in the building sector. This includes route optimization for transport. This includes reduced curtailment of renewable energy, which can happen through better weather forecasting, and so on. So many of these interventions, if we were to scale them up, the total emission reduction potential over the next 10 years is 3 times as much the total emissions that are expected from data center electricity consumption. In other words, the potential is far greater than what is currently being realized, and we don't currently have either the full understanding or all the tools necessary to unlock these emission reductions, which is what I hope that your work here will kind of throw light on exactly how that transition can be made from what we currently know, what we currently have, towards action, towards material results at the end of the journey. Now, I will leave you with maybe 2 or 3 things that are of particular interest to the IEA. So these are the issues that we would like to see more research on and more interventions, and therefore for us to highlight some of these interventions in our analysis itself. So one is is around cities, which is something that was already covered in the earlier presentations and interventions. But we would like to have a better understanding of the real-time, transport energy use. So how do people move? How do goods move? What are the energy implications of that? We would like to have a better understanding of human settlements. Where do people live? What types of houses? What types of implications that has on land use? We would also like to understand energy access. This is a major issue. Today, hundreds of millions of people around the world still lack access to clean sources of cooking energy as well as electricity. So we'd like to have a better understanding of where the biggest challenges lie and what types of interventions can help us kind of cross that bridge. We'd like to have a better understanding of resilience. The presentation prior to this on floods was a good example of it, but we'd like to understand how that impacts energy infrastructure, because ultimately we need to ensure that the clean energy infrastructure that we are creating for the future is also resilient to climate extremes. And finally, of course, we also want a more real-time tracking of emissions. So we'd like to have a better understanding of methane emissions, of particulate matter, and others, so that we're able to have better, policy advice coming out and ways to address these in a more real-time fashion. So I'll stop there, and I'm looking forward to hearing from the other speakers as well.
Thank you. Thank you so much. Raphael, please introduce yourself, explain why you're here, and react probably on what, for example, Ilias said.
Thank you very much. As well, I would like to share my congratulations for the report. Thank you very much. Lobbyists have very short attention span, but you managed to catch our attention. So I will disseminate this to my team as well. There's a lot of insight. Now the challenge is how indeed to translate these insights into action, really. So a few words about Digital Europe. So we are a trade association based in Brussels. And we gather hundreds of members across the board, really all the spectrum of what we call digitally transforming industries, so big corporations like Google, who is somewhere, but also innovative SMEs, as well as national associations. And we advocate for a competitive Europe, a digital Europe, where everyone can prosper through digitalization. So, I mean, we mentioned tipping points, that the planet is reaching some very concerning tipping points. I think AI is also close to a tipping point, let's say, because as you know, Europe is lagging behind on AI and critical tech. We know that the US is faster, scales up much better than we do in Europe. Unfortunately, we haven't been very good at nurturing or entrepreneurs and to really invest in scaling up. Look, I mean, I've just heard that actually the EU is going to create a new scale-up fund, which is, I think, very good news. But this is really a very important moment. You might know that there is a whole reflection around cutting red tape, around simplifying the rules, but also the negotiations on budget are starting very soon. And this is also one of our big priority to make sure that a sufficient part of the EU budget is really dedicated to digital, not digital for the sake of digital, but digital for competitiveness and digital for good. So actually, Digital Europe has just launched a big CEO declaration on AI and tech. We have more than 50 CEOs already signing it. We want to expand it to really pass the message that, yes, there is a tipping point and we need to really ensure that Europe is a fertile ground, as beautiful as this cover, where all the AI and tech plans can really flourish. Because AI is really transforming very important sectors where Europe is excellent. Green tech, renewables, imaging equipment, advanced manufacturing. So again, it's not AI for the sake of AI, but how AI can transform those sectors. And actually, Sid used one of my speaking points. So I'm not going to thank you for that, Sid. Talking about potential, Indeed, I think the figure you used about the fact that through AI, the energy system could cut emissions by 2035, equivalent to 3 times of what data centers are using as emissions, are producing as emissions right now. So, I mean, Europe has not been as fast as the US, but there is still hope. And the question now is indeed, how do we scale? How do we scale those projects? Because we've heard like very promising, very interesting projects in, I think like the urban planning is one where I was thinking, but how do we replicate that? How do we make sure that, you know, any municipality can actually use similar algorithms to really improve the life of the citizens? How do disseminate? How do we scale up? So we need to really focus on these enabling aspects. Of course, that doesn't mean that we have to totally be oblivious to the footprint of technologies, that's for sure. We need to reflect on how to embed really sustainability criteria into the use of AI and tech. But on energy, for example, which is really a core area on which we are working at Digital Europe, we do have some ideas. So first we need access, and I think this is valid for many areas, that we need access to high quality data. And for this, we can, for example, use some common standardized data frameworks. And I think the EU is very well placed to do this harmonization work. We need also, of course, to streamline the regulatory framework to ensure that we have consistent implementation. We mentioned implementation, that is very important for companies as well, and to invest in cross-border projects to, again, scale up AI and tech. I will stop here.
Yes, please. Thank you so much, because let's not steal the show. We're here to ask questions to the researchers. So please, can you, each of you, introduce yourself, explain the key insights from the reports that you have worked on, and also maybe perhaps already react on what they said about data center energy consumption, about like how to scale up, where should the money go? Anything you can answer already, go for it.
Hi, my name is Lan Wang Allenson. I'm associate professor at Stockholm Resilience Center and have a background in global hydrology and work on issues such as how water cycle changes affect ecosystem resilience, planetary resilience through the planetary boundary framework that Jonathan showed, and vice versa, how ecosystem resilience affect water cycle changes. So I wrote the chapter on fresh water for all, together with Nela Knektus is also in the audience, with Ingo Fetzer here, and Romy Locheris, who is not here today. And so water is a very broad issue. In fact, often when we think about water, it's a liquid, visible water, and the use of water directly, you drink it. And already there, it's a huge issue, because we know 4 billion people are suffering from water scarcity at least 1 month per year. But water is also very important in very hidden ways. Well, it's providing the food, the textile, the things that we wear, as well as for energy productions, but also for supporting Earth system processes for sequestering carbon. At least 1/4 of the carbon emissions we emit are absorbed by land systems, which are sustained thanks to the water cycle dynamics. So we try to, in this chapter, have a quite holistic view on water for all different purposes. So ranging from filling data gaps, improving data limitations in agriculture system, which is the largest sector using water, but also in more precise applications, such as what we saw from Beth's presentations on flood mapping and increasing the predictive power of models, and also some of the more sort of at the frontier kind of exploratory use of AI in helping decision making, in catchment, water resources management. But also for understanding, because water is so much, not just the water in itself, but it's in interactions with the climate, with land use. So when we deforest, we change the precipitation patterns. And when we respond to water scarcity, we might respond by building reservoirs. But again, that reservoir building also gives a sense of that we have water available, which again increases water. So there's also a social feedback there. So water issues are quite, as many sustainability issues, quite complex in disentangling what is causing what and what are the different dynamics, and also just making sense of it. So AI, we see that also has a potential in helping disentangling this causal mechanism, attributing not only changes in water to climate change, but also attributing to say what caused the precipitation change here. Is it actually provided by forest providing the moisture from far away? And how can we make that information more readily available to decision? It's in the science space, but it's not communicated as clearly as it could for decision makers and managers. And then, of course, we also can't forget the AI is not just an abstract digital thing in the space. It's also physically embedded in water cycle, just as everything else in society. So the AI is also using water, the data centers, the manufacturing of the components needed for AI. And there's projections saying that in a couple of years, the AI might be using as much water as the whole population of Canada. So it's used for cooling directly, so it increases water temperature. And so at the same time, when we have climate change, water temperature increases, it also goes back to that higher temperature might threaten the operations of data center. So it's really need to consider AI, both sort of what is AI benefiting. Many of the data centers are already located and planned in water-stressed regions. So who is the AI benefiting, or is it aggravating water stress in some regions? So to think about AI infrastructure as a whole more holistically. So these are some of the key insights from our chapter, I would say.
Yeah, so my name is Ingo Fetzer. I'm a researcher at the Stockholm Resilience Center. And yeah, together, I mean, I'm interested in, or I'm looking at understanding Earth system processes. So how different processes work together, and and how they're working together. So which one are the relevant ones and how they're working together. And then together with the colleagues from PIC and other colleagues here from Stockholm Resilience Center, we are trying to understand also kind of how humans actually are affecting these processes. So either the process directly or the interactions between them. Because I mean, this is also a kind of relevant understanding kind of, where are global tipping points, but also where are climate tipping points. I mean, for this, we have to bring together quite a lot of like large data sets, and they come from different sources. They have different resolutions and whatever. And so to get this type of understanding. And then while we have quite a good understanding on all the geophysical processes, I mean, we're pretty much lacking so far is understanding what does the biology part does. So that is something that is a bit like, still it doesn't follow kind of regular rules everywhere, or following different rules or non-rules. We have no understanding. And here I'm also not only talking about like ecosystems and biodiversity, but let's say also the other important component of the Earth is kind of humans. So kind of human decision making. So human decision making actually drives a lot of kind of changes in Earth system process, or that kind of build up finally locally, and it can be so like small communities changing something, and that kind of if people do it everywhere, that kind of aggregates on a global level. Climate change is a good one. Is one of the good understood process, but I mean there are a lot of other ones. The other ones also political processes, political decisions. That means I don't know what the policy decides. Maybe kind of translates into the world again. Kind of emissions is one. But then also, I mean, human society have created something like the economy. Economy is something also that, I mean, if we just look at satellite data, you don't understand why suddenly massive land use change happens here, because of without understanding the kind of economy. So that where flows go, where food is produced, where do natural resources being exploited, and so on. Because this is also a process that is not kind of is kind of not built in our Earth system models. So right. So and we see like the potential of AI kind of by that enables us bringing all, or for understanding what are actually the problems in the world, we need to kind of bring all these data together, and also to kind of find solutions for the current problem that actually I would say humanity has, it has been created by all of these elements, and we need kind of to only by bringing them together, we can find solutions. So there's no kind of one way or one silver bullet that would help us here. Right, then what else? Right, then when it came to the chapter, so I was contributing to several chapters. Like I was kind of amazed how like the kind of the plethora of different methods that's out there. So I mean, so AI or it's a bit like a Cambrian explosion right now. So there's been like a lot of different methods being developed. Some of them are a bit still, I don't know, in the process of evolving. Maybe some of them going to disappear again or evolve into something else. But I think that is there's quite a lot of potential there. And as I like, we need this also kind of to understand, to get an understanding of kind of the poly crisis we are actually in and how to solve it.
Hello, I'm Maximilian Beth. I'm a researcher at the Potsdam Institute for Climate Impact Research and the TU Munich. And in my research, I explore how we can use AI to improve Earth system models in order to enhance our capabilities to understand the changing climate in our planet. And as we also write in the report on the section on the Earth system as a complex system, there is really a plenitude of possibilities to achieve that. And we've seen actually also already today in the presentation a lot of these possibilities. On the data side, we've seen these amazing capabilities of AI technology to analyze satellite data in a way that manual human analysis or like also classical statistical tools could never really do. But even for modeling side, and this is closer also to my own work, and this is also something that we write in the report, there's plenty of possibilities to use AI. But at the same time, though, we can't forget the models that we have because we only really have high, like very reliable data for the last few decades. And for the Earth, the last few decades are not a very long span of time. And of course, we also don't have any data of the future yet that we could learn the climate change on, like train the climate change an AI model directly on. So a lot of the research that also has to be done and that we also basically already doing also has to be concerned with how we can really combine this in a form of like hybrid approaches that basically use AI to enhance the physical simulation models that we have. And there are a lot of very promising approaches there that primarily lead to models that are faster and that reduce uncertainties. And faster might sound like a technical thing, but if we have faster models, then we can also make more projections that are also more tailored to the needs of our stakeholders, that can also optimize for like on a much more on a regional level where we actually want to look into projections and where we want to understand climate change. And yeah, there are a lot of possibilities there, but in the end, basically in this field, we want to have the best of both worlds. We want to have our physical simulation models, but we also want to learn from data with the help of AI to really improve these models. So maybe also addressing already a few points from earlier, I think this is also already one example where we basically, with AI technology, we have to always also keep in mind the actual target, the area that we are looking at. There's this nice quote, if you have a hammer, everything looks like a nail. And this is something that we really shouldn't fall into. We shouldn't always apply the deepest, most complex model because this is just a waste of electricity and power, basically. So important then also in the like ethical and sustainable usage of AI is really choosing the right tool at hand for the problem you have, talking to the domain experts that know, or like that have a better intuition probably also what the right tool might be. And then basically to also include the public then later, document this in a really transparent way where, of course, this is also been in academic classes, it should be the standard of open science already anyway, to basically make it very clear from the beginning, what is the data that you're using so that people can also see what kind of biases this data might possibly have, what models are you using, and then also ideally basically make it possible for also stakeholders, but also the public to make inference on the models and actually use them.
Thank you so much. As you are so many, we will have to stop here. But you will stay during the networking and be able to talk to each other and answer each other. And so thank you so much for coming. Can you go back to your seat? Because now I'm going to give the difficult task to Victor, Jonathan, and Drew to come, to conclude, to wrap up, and to also possibly address what the policymakers just addressed, their concern they ask. Would be very grateful if you could conclude on that. Thank you.
Okay, thank you. So, thanks again for the opportunity to be involved actually in this report, and thanks for all the interesting discussions today. It's been, I didn't actually know Victor before this experience, or indeed Jonathan or many others. So it's been that side has been amazing. Getting to know these pioneering and very thoughtful scientists. And talking of being thoughtful, I think it's very interesting to hear these, to see this, what I think is a very balanced discussion of AI with the huge potential on the one hand, and then but also thinking about some of the various issues that we have to think about in terms of rolling that out responsibly, whether that's the environmental footprint in terms of energy or materials or potential biases, etc. So there's something that we take very seriously too. I think I think this was hinted at earlier, but one way we can approach that is of course on a case-by-case basis. So we can think, there are as we saw earlier, many different flavors of AI and many ways that we can apply it. And I think one of the things that most of us involved in the report share is that we think there are many cases where the benefits significantly outweigh the potential downsides. And so if you want an analogy, and this is meant to perhaps be thought-provoking, think about something like transport. Many of us have flown, and maybe when we get off the other end, we get in a car. And actually the energy and materials involved in both building and running vehicles is really enormous. But hopefully we think about that and we think on a case-by-case basis and think, is this a case where I think that the benefits outweigh the risk? And we can take that same approach to AI. I think another thing which is very interesting is to sometimes think about the alternatives. So sometimes we can do things with AI that simply couldn't be done any other way. And that's a special kind of benefit, which is incredible. Another one is sometimes you might want to think about the alternative ways you could have done something. So one example is, and just to give you a tiny little story, I was at a conference not too long ago, and I mentioned the fact that potentially with LLMs, we could geo-index enormous numbers of documents for the first time, potentially, which would be amazing for ecology. And somebody mentioned the fact that this would potentially take a lot of energy if it was a lot of LLM calls, which is quite correct. But of course, the alternative to that would probably be, which we do quite a lot now, would probably be to have that done by human annotation. And that means potentially hundreds of humans in their separate offices, each running a PC and a fan and a heater and air conditioning and doing that themselves. So sometimes that kind of like for like comparison can be very interesting. Like, for example, the energy that it would have taken to actually directly measure the shape of every known protein would be absolutely unimaginable, but we're able to do that with AlphaFold with AI. And so it's a very nuanced business, and you can probably see that that's going to sound very optimistic. I do want to just reinforce that the material, the energy and material potential consequences, as well as other risks of AI, are real, and so they are something we take very seriously as well from where we are. And perhaps I should also nuance that slightly by saying those of us involved in the report, like myself as author, we are speaking primarily as individuals here. But I don't mind also saying that in places like Google DeepMind and analogous places, it is something we take seriously. So I think it's great that that's been discussed and highlighted in the report.
Yep, now it's on. Yeah, I'll be quick. The work on the report was really rewarding experience for me. I learned a lot, I think, and it's bringing some more systematics to this field where, like I think Maximilian said, everything is bubbling up and people are experimenting, and or Ingo said, it's a Cambrian explosion, and we can see this in our lab where, especially the young PhD students and so on, they're using it so much, like doing AI-driven literature analysis, scanning hundreds of thousands of papers, basically, and it's something you couldn't just have done just 2 years ago, and it really boosts the science. And then doing, large language model-driven agent-based modeling and such things. So we're experimenting a lot, but we also see the big picture, and we're really trying this integration of the triangle of sustainability more in our work now, the social, environmental, and economic dimensions. And I think, so it has been a great experience, and let's follow up on this.
Awesome. First of all, thanks everyone for sticking around. We're a little bit over time. some reflections. I mean, of course, it was great to write this together, but I wanted to feedback a little bit on the panel. If anyone needs help with writing a call, I'll be happy to help out. That's not a problem. But there was another message around acceleration and limits and what's like blocking faster assumption of or use of these models, et cetera, et cetera. And I think to me, that was never the purpose with what we wrote. And that was never the narrative. The way we framed the work was, what is out there? Are we asking the right questions? Are we focusing on the right areas? Which questions would matter to people and the planet? And then reflecting on those and chart out a new terrain to do that. And I get the sense, I mean, since we are in a policy space, that there is a rush to AI implementation, and that was never our purpose, to promote AI implementation. But when you do that, science is a very strong partner. Independent, strong inter and transdisciplinary science can help you evaluate that implementation and make sure that that implementation is done with care for both people and the planet. So I think that I see our role more as that rather than accelerating uses in itself.
Because I realized because I wanted to respond to the panel, I focused on some of the downsides and risks and so on and how we could take those seriously. But one of the things I took away from the workshop, which was amazing, again, meeting all these new people, firstly, some really amazing examples of the use of AI in sustainability already that I wasn't aware of, almost to my shame. And I'm glad that we've seen some of those presented today, actually. So they're really amazing. Another thing I took away, which I think is something the Stockholm Resilience Centre has always thought about, but I think I personally perhaps have not thought enough about, is the deep interconnected nature of sustainability between, as we saw, people, people using climate, nature, people, all of these systems together. And reflecting on that a bit today, it's making me think, if we really do want a sort of an understanding and even a predictive ability for those interconnected systems, I think without AI, it's not actually obvious that's possible. It's so complicated. And of course, we can make some progress and perhaps we can on thinking through, but the AI is, these modern techniques are so different to everything we had before. The way we can integrate enormous amounts of data, including some of that really messy human data that tends to surface in the shape of language and documents, not as ones and zeros, and to somehow put all of that together. So, it's not obvious that it is possible necessarily to understand something as complex as the Earth system, but I think it is fairly clear that it's not possible without AI, and it's worth trying with AI. That's the thing I've taken away from it, I think.
Thank you so much. Sorry that it was such a rush. Thank you all for coming. Please stick around for great networking, continue conversation over a drink and something to eat. Thank you so much to the online participants. If you see me, hey, thank you so much. And for the people on site, please join me outside for a group picture. Thank you, guys.